So question number 1, would anybody like to try it? So we're trying to show that these two triangles are similar. We're going to have to use the AA similarity theorem. Randall?
35 plus 90.
Okay, 35 plus 90.
Equals 125 and subtract out 180.
Okay, and so what you were finding was angle L, and what did you get?
55.
That's perfect. So we have 55 degrees. Now, which two sets of angles are congruent?
L1.
So we see that angle L is congruent to angle M. That's perfect. And what's the other one?
JP.
Yep, J is congruent to angle P. Now, since we've shown that two angles are congruent in each of the triangles, we can use the AA similarity postulate, which is what he's going to use. And then we are going to write out our similarity statement. Do you want to do that one as well? Okay. So if we're going to write that out, remember we write out our triangle symbol, and then we're going to write out JLK is similar to triangle, and then we have to make sure that our angles match. So J corresponds and is congruent to angle P, so it goes next. L corresponds and is congruent to angle M, goes after that, and last but not least, we have N. So that is our answer for our first one. We see by AA that we know that these two triangles are similar. The second one, does anybody want to try the second one? So if we're looking at the second one right here, we see that this mark here tells us that they are congruent. Then we have 38 degrees and 72 degrees. Is 38 degrees and 72 degrees the same?
No.
No, it is not. So we say no, these are not similar. And then last but not least, we want to find the value of x. So to find the value of x, we have to show that these are similar triangles first. So the first thing we need to do is show that we have at least two congruent angles. So I would like to label these. I know I didn't label them on yours, just to make it a little clearer when I'm referencing. So A, B, C, and then E and F. So we see that angle A is congruent to what?
Angle what?
Angle A is congruent to? So we see angle A is in this small triangle, and it's also in our large triangle. So it is congruent to itself because it's in both triangles. So we see that angle A is congruent to angle A. And then after that, you hear Nemo's voice in your head because he really likes this one. We see that we have two parallel lines. Two parallel lines cut by a transversal, thank you, allow us to know something about these two angles. They're going to be congruent because what type of angles are they? They are corresponding. So remember, they are corresponding angles. We could also say the same thing up here, that these are going to be congruent because they are also corresponding angles. Two parallel lines cut by transversal. They're in corresponding position. So what we can do is we can pick either pair of those. So I'm just going to go EB because that's the one that I saw first. E is congruent to angle B. And therefore, we see that these two triangles are similar. So after that, we want to be able to use the proportionality of the sides. So I can now relate those. So my smaller triangle, we have AF on top. What side corresponds and is going to be proportional to AF?
AF?
Yep.
AE.
So we see here we have F. So AC is going to be what's going to go on bottom. And then up here we see that we have EF, smaller, so it goes on top. EF, it stays with the triangle. And then we see that we have BC, which is in the same triangle with the AC. So whichever triangle you decide to start with, and this one did not tell us which one to start the ratio with, you want to make sure that you stay consistent with it being in the numerator or the denominator. Now we're going to fill in the information we need to know. So AF is what value? And then we have that over. It's going to be 18 because it's 12 plus 6, which equals 18. And then we have it equal to 10 over x. So now we have to cross multiply and solve. I am going to move back over to my other side. I'll change colors. But I'm going to pick this up right over here. We see we have 12x equals 180. 18 times 10 is 180. We want to isolate for x, so we're going to divide by 12. We divide by 12. What is my x?
15.
It's going to be 15. Nice job. Okay, so any questions? Okay, so 7.4, showing triangles are similar by side, 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 and side, angle, side. We see using this that we have our objective, which is to show that two triangles are similar using SSS and SAS. similarity theorems. So please write your objective at the top. So the first two things, by that I mean I cut them out. We see that we have side similarity theorem. So if the corresponding sides of two triangles are proportional, then the triangles are similar. So previously we've shown that two triangles are similar by going through the angles being congruent and then the sides being congruent. Not congruent, proportional, I apologize. And then now we've also done where you can show two angles that are congruent, makes the two triangles be similar. And now this is telling you if all of the sides share that common ratio, they will also still be similar. Okay, so after that, we're able to use this in our first example. For our first example, you have to know which one is B. So I'm going to call this little one B and this one A. It says, determine whether the triangles are similar. If they are, write the similarity statement and find the scale factor of triangle B to A. So for it to be B to A means that B has to be in the numerator. I'm sorry, I have to click it one more time. Right here. Back to this. So we have B, we have A. Okay, so we want to double check that. So we need to now write out those ratios. So if I start with B to A, that means B goes on top. I'm going to start with TS. What side would be the one that we are going to relate to TS? So we're going to go QP, which is going to be equal to, if this works out, SU. And which one goes with that? PR. And then we have UT, which would go with RQ. Yep, nice job. After this, we're going to substitute in what we know. So what we know is TS. TS is 4 over QP, which is, yep. And then we go to SU, which is 6 over 12. And last but not least, we have 5 over 10. I'm going to reduce this using a different color. So when we reduce this, what goes into 4 and 8? 4 goes into 4 one time. 4 goes into 8. Okay. Over here we see we have 6 and 12. What goes into 6 and 12? 6 goes into 6 how many times? 6 goes into 12 how many times? Okay, and then we have 5 and 10, and we know how this is going to go, 1 and 2. We see they all have that same scale factor, that common ratio, 1 to 2. And so now we can write that similarity statement. So our similarity statement is going to begin by saying by. We just use side. And I like to put sim theorem. I'm probably not going to be too strict on that. If you just write by SSS, it's probably going to be good for me. We know that triangle TSU is similar to triangle, and then we have to make sure that those are the ones that are corresponding with it. So we see that T corresponds with Q, bless you, and we see that S corresponds with P, and we see that U corresponds with R. So we see that these are proportional or similar based on their proportional sides. Okay, once again, I'm going to label these for us. We see that this is going to be B. Oh. I apologize. Come on, Jenkins. Okay, let's try this again. So we see this is going to be B and this is going to be A. And let's call this one A and this one B. So using that information, we are going to write out our proportions. So let's start with the first one. So if I'm going to begin with, it's B to A based on what we had from our first problem, which means B is going to go in the numerator. So I'm going to start with AB over which side corresponds to AB? XY. Okay, which is equal to, let's do BC, which corresponds to, nice job. And last but not least, we have CA, which corresponds to ZX. Nice job. Now we're going to substitute in what we know. So we're going to begin with AB. AB has a length of, so I'm going to put that up top to make sure I have room. So it's 15 over 10, which equals, we have now BC, which is 12 over, and last but not least, 18 over 12. Now we want to see if we can get these to reduce to the exact same ratio. So I'm going to begin by seeing what is in common between 15 and 10. So it's going to become 3 over 2 because we know we can take out a 5. So 3 over 2. What can we take out of both 12 and 8? 4. So what happens there? 3 over 2. And then what can we take out of 18 and 12? 6, which becomes, once again, 3 over 2. So we're going to write that similarity statement one more time. So we're going to say by, we're still doing side, side, side. Triangle ABC is similar to triangle. And then once again, I've got to match this up. So I see that A matches with X. Yep, exactly right. Y, Z. Nice job. Okay. For question number 3, I would like you guys to take a second. Oda, what were your proportions? So B to A. So let's start with, yep, Q over P. Which one did you relate to Q over P? LM. That's fine. Okay.
I said PQ over LM.
That's more than fine. So that one, you have to be careful with it. It's B to A. So B has to be in the numerator. So now that you have that one, what was your next one?
Do we even test on this one? Do we even test on
Time out. Okay. What was next, guys? I cannot hear him. What was next? Sorry, Coda.
QR over MN.
Okay. Which is last we have?
And then last we have RP over
Over
NL.
ML?
NL.
NL. Thank you. Okay, now we're going to substitute in what we know. 12 over 12. 13 over what? 15. 5 over 9. Okay, so now we're looking at this. So that's because you wrote them in reverse, so you have everything is a reciprocal. Okay, so now, can we reduce any of these to be the same thing? No. So Kaylin, what's our conclusion? They're not similar.
Oh, that's not fair.
Okay, so side angle side similarity theorem. If an angle of one triangle is congruent to the angle of a second triangle, then the lengths of the sides that include these angles are proportional to the triangles, then the triangles are similar. Let me try that again. Okay, so when we look at this, you see here that they're saying if angle X is congruent to angle M, then the two sides that form that angle are going to be proportional. So we see that YX would have to be proportional to NM, and we have to see that XZ would have to be proportional to MP. So we see that the two that form that, so remember with side, that angle is wedged right between those two sides. It has to be right adjacent. All of them have to be able to touch. So once again, I gave you this one, so I'm going to go to our next slide. We have example 4. With example 4, we're going to start and we're going to look at which angles are congruent. So to use side, angle, side, we have to state which angle is congruent. So angle C is congruent to F. Okay, and then now the two sides that make up those angles, we want to see that they're proportional. So I'm going to do BC over EF. And then we see we have CA, which goes over FD. So those are the two sides that make up the outside of that angle. They're the segments. And then we want to substitute in our numbers. So we have 6 over 10 equals 3 over 5. We're going to reduce our first fraction. When we reduce 6 over 10, it goes to 3 over 5. So we can now say by side angle side, and we know this because we proved that there's let's try it again. That there's an angle that's congruent in both, and then that the sides that make up that angle are proportional. So by side angle side, triangle ABC is similar to triangle DFE. So our first one here, we see we have two triangles inside one triangle. So you see here you have triangle VWX and triangle VYZ. So if this is something hard for you to visualize, there's nothing wrong with drawing these triangles out to the side. So I'm going to draw them over here. They're a little shakier than I'd like. So we see we have WVX and we have Y. So our first step is to see, do we have a congruent angle? So which angles are congruent?
Those triangles look more like a Dorito than like the way like.
Oh, that's not on the corner.
Thank you, I guess. Okay.
No, what's the one show with the bear who's always trying to get that?
Okay, so we look here and we want to see which angles are congruent. So what angle is congruent in both triangles?
V.
What'd you say?
V.
We say it's going to be V. They both share V right here. Bam. So we can say that V is congruent to V. So I'm going to go over here. I see that V is congruent to angle V. And now we want to see that the sides that make up that angle are going to be proportional. So I'm going to do VW over VY. And we have VX over VZ. So at this point, I'm now going to fill in what I know. So we know that VW is going to be 4. We know that VX is going to be 5. So I know this is going to be 4. This is going to be 5. But I need to know what the length of VY is. Well, VY is this entire thing. So once again, we're going to add our side lengths. So 4 plus 8 is 12. 5 plus 10 is 15. So you have to add, I'm sorry?
What did you? Oh, they on the side.
So we got these because this segment and this segment make up the entire length, so we're going to have to add them together.
I didn't see the numbers on the side.
So we have to reduce this, and I hear you guys say it. So what goes into both of these? 4. 4 goes into 4 one time. 4 goes into 12 3 times. 5 goes into 1 one time. 5 goes into 15 3 times. So you see your scale factor is what, Rio? 1/3. Okay. So we see that we have our scale factor being 1/3. So by angle, nope. Yep. Side angle side. Sim theorem. And then we really don't even have to do too much work. We could go through and list that out, but we could also just by similarity theorem. We could just go back up to what our question said. They already wrote it out for us. So we can just go up there, see that triangle VYZ is similar to triangle VWX. Okay, so what angle is shared between the two triangles? What? Okay, so what angle is shared between the two?
L.
Angle L. So we see that angle L is congruent to angle L. Whew, that's an ugly L. Let's try it one more time. Angle L. And then we want to talk about the sides. So if this is something you struggled with, you could divide this into two triangles. I didn't do it on this one. Yeah. You want to try it, Randall? Okay, so which one did you write first? LQ goes over LP, nice job. And then we have LM over what? Nice job. Okay, so the most common error here that I saw on many people this hour and my other ones was that they related just QP and NN.
That's what I did.
That's not a full triangle, right? So that is going to be a quadrilateral because it had 4 sides. So you have to be able to see the full shape.
I did PQ over LQ.
So you did PQ over LQ. So that's only half of it. So the big triangle, the small triangle is just this part here, and the big triangle is as if this middle part's not there. So it's the whole length out. Because if not, you only talked about just this where you truncated it. So now we are going to compare those ratios. Randall, you ready?
14 over 35.
14 over, ooh, be careful. So it's LP, so it's going to be over the whole length. So 14 plus 35, which is 49. And then our last part over here, we have
16 over 56.
beautiful. Okay, so 16 over 56. What goes into 14 and 49?
7.
7 goes into this 2 times. 7 goes into this?
7 times.
Perfect. Over here, what goes into 16 and 56?
8.
8 goes into this how many times?
2.
Next one?
7.
Okay, we see they are the exact same ratio. So once again, we can make our statement by side angle side, sim theorem. We know that triangle, and I'm going to do LMQ. Oh, once again, it's written in the problem, so I don't necessarily have to look up there, but we can still do it. It's similar to triangle LNP. But we could have went around and looked at the corresponding angles to make sure that we listed those correctly. So here, we want to see if we have two angles that are congruent. Which two angles are congruent?
H and M.
Yep, angle H is congruent to angle M. And now we have to come up with that ratio for the sides that make up that angle.
GH
Over
LM.
Over LM equals.
HJ over MN.
Beautiful. Then we're going to substitute in what we have. So GH, what do you get?
8 over 6.
Over 6.
12 over 8.
Okay. So if we reduce 8 over 6, how does that reduce? We get 4 over 3. If we reduce 8 over, or 12 over 8, we get what? 3 over 2. So we have 4 over 3 equals 3 over 2. Is this true? It is not, right? So therefore, they're not similar. Let's try that again. Therefore, not similar.